button. Oh, yay. So a part of the segments are from a friend of mine at Bowie State, Latanya Brown Robertson, who wanted me to answer these questions. So I'm going to answer these questions with you and also share the recording with her. So yeah, I just want to make sure that she get a copy and the rest of the world if they so choose. But it's great to be back in Carolina. As they say, nothing can be funner than being in Carolina, right? So I have family down in Red Springs, so it's good to be back virtually. Yeah. So just to talk a little bit, everybody has a different definition of data science, right? So kind of what is data science? On the right-hand side, we see a Venn diagram where we have the interplay between data science, AI, ML, DL, but then you ask somebody else, they say, no, data science is everything and everything lives in it. So I'm an applied mathematician, so I tend to be sloppy. So I'll just put the whole, I guess, kit and caboodle in with data science. So usually I'll just say data science and data science related, whatever it is, which to me is more fun and all encompassing. But if you try to really dig deep and if you try to go first principles and get some definitions, I just went on the dictionary, was like, oh, here are some definitions. One for AI, looking at the theory and development of computer systems that can perform tasks that normally require human intelligence. Put in machine learning, I get it. We get another definition. And then here we have deep learning, it's the machine learning based on artificial neural networks. And then you say, okay, if Oxford has all of these, they should have data science, and then data science comes up empty. I was like, really? No definitions found for data science. So what is one to do? Okay, so people ask me all the time, how do you define data science? This is the best I have, right? And you can have your own definition. It could be different. That's okay. This comes from IBM. It says the goal, so it's not a robust definition, closed, right? The goal of data science is the extraction of useful information from a data set. So we have to agree on what a data set is, right? Because set in math is an undefined term. You have to say what is the data set so we know that it is a data set. So you can't really just define it explicitly. We end up with a little loopy thing going on. And then, so once we know what the data set is, then we extract useful information. So I say useful to whom, right? So communication is a big part of data science. And there's different ways to extract. It could be, people could be on the continuum of actually doing the extraction, cleaning up the data to get it ready. I mean, so there's a lot of different ways one can enter into this, what I would call a dynamical system. SciEM also has a journal on math and data science, and this work advances, they actually say mathematical, statistical, and computational methods in the context of data and information sciences. So they have the two interplay. Some people could say that data is information, information is data, but those are philosophical debates that I try not to get into. That could be fun for the bar talk sort of thing, right? But really, at the end of the day, there's still no consensus on the definition of data science. But it's what I do. It's fun. It's, I set up other people to do it as well. So just a little bit about me. I'm originally from Evansville, Indiana. So this is kind of my educational work trajectory. So I'm a bulldog. That's how I started out. And then I went to undergrad at Spelman College here in Atlanta. I went to grad school I majored in math at Spelman, minored in Spanish, and then went to UConn, got my master's and PhD in mathematics. My area is applied mathematics, kind of in the classically trained sense, where I looked at a system of PDEs and look at analyzing systems of PDEs. Then I went to Duke University, around the corner, where I looked at mathematical biology. I wanted to get closer to the application of mathematics to solve biological problems. So I had looked at a gonadotropin releasing hormone secretion model to try to use math to describe what was going on there. Then my first tenure track gig was at the College of New Rochelle, that's outside New York City. It's kind of expensive to live there. After a couple of years, I went back home and was a professor at the University of Evansville. I got tenure and promotion. Then I went to Howard. Then I earned tenure again. Once is not good enough. You got to do it twice. 2 years in a row. It's kind of crazy. And for the last 3 years, I was at, minus this past year, I was at the National Science Foundation where I was a program director. I think when I started there, I didn't know what I was doing, but about a month, we kind of all figured it out. You know, they say that when you become a program officer at NSF, it's like being a grad student. You get there, you're like, what are we supposed to do? Where are things? We don't know what we're doing. Like, who are people? Yeah, but it was fun. It was a great experience. And then I got tapped on the shoulder to consider being the inaugural director of the Atlanta University Center Data Science Initiative. And it was appealing to come back home to the Atlanta University Center. Spelman is a part of the center. And I'm also a professor of mathematics at Clark Atlanta. So I have 2 hats. So how do I get into data science, right? I'm an applied mathematician. I like all things dynamical systems, non-state finite difference schemes. That's my main area. I got into data science really through students and through the humanities initially. So way back when, a decade ago, right? A faculty member at the university was like, hey, why don't you come co-mentor this student with me and come be an affiliate for the Digital Humanities Laboratory? So I was like, sure. And so we looked at text analytics and things. So my entryway into data science was through the humanities. And then 2015, I hosted StatFest at Howard University. And StatFest, if you don't know it, now you know it, that's happening September 17th and 18th. That's hosted by the American Statistical Association. So check it out, it's great. It's gonna be online. And then I did a workshop at Howard with the sociologists on multivariate research methods, drove my car out to Utah through Wyoming. That was an adventure. To the Park City Math Institute. That was a lot of fun. They have programs for multiple levels, undergrads, grad students, faculty, you know, whomever, right? Basically, we got to look at the mathematics of data 3 weeks. It was super fun, all you can eat, and there were 2 hot tubs. I mean, it was a great time. So I ended up in a group that looked at how do we prepare students in data science? So it ended up resulting in a publication on the curriculum guidelines for undergraduate programs in data science. So that was a lot of fun to do. You know, students were like, we need to do more data science. So I taught topics courses. My student graduated in 17. He ended up going to JP Morgan, employing machine learning to address cybersecurity. So I mean, I tend to find myself educating students who end up going into data science. I don't know if that's by accident, but that's just what it's fun. And then when I went to NSF, I led their IU's Improving Undergraduate STEM Education Data Science portfolio. And I also worked in the Convergence Accelerator, convergence of different fields to solve problems of societal interest. One of them was AI and future jobs. Another track was AI-driven innovation via data and model sharing. So this data science has just kind of been something that I got pulled into by students and just out of my own curiosity there. So in August of 2020, I became the inaugural director of the Atlanta University Center Data Science Initiative. And one of the models here at Atlanta, you know, Clark Atlanta University is 2 schools put together, Clark College and Atlanta University. So the motto of Atlanta University is, I'll find a way or make one. So that kind of is our mantra here at the initiative. And so this is my friend's questions that I told her that I would answer. So I told her, I said, you know, if I gave a talk, what would you want to know? So I'm just kind of gonna go chunk by chunk here. So first she said, how do you develop and maintain interdisciplinary faculty engagement? Because in data science, you typically have multiple people from multiple disciplines coming together, and how do you develop and maintain that? And what is your research community model? So the Data Science Initiative lives in a community of organizations. So the initiative lives in a separate nonprofit called the Atlanta University Center Consortium. So the consortium, the board is made up of the 4 presidents of Clark Atlanta University, Morehouse College, Morehouse School of Medicine, and Spelman College. So the initiative works across all of these 4 different institutions and also another institution, the AUC Robert Woodruff Library. So we're kind of in this conglomerate space. We're co-located, we're right across the street from each other, but the institutions are distinct and, you know, silos are real. And one of the things that we like to do is build this community across disciplines and across the institutions. We were funded a few years ago by an $8.25 million grant from the United Health Group to basically train up and diversify the data science workforce. So just a little bit about the Lane University Center. So you see all the blue circle things over there. So all the schools literally are right across the street from each other, situated right near downtown Atlanta. We're about 90 years old. And so back in the day, 1960, the students of the consortium joined together and actually did an appeal for human rights, basically to advocate for rights for African Americans. And so, and that's the young Julian Bond there, who graduated from Morehouse right when he was leading SNCC. And so we really build our data science initiative really on the strength of our students in their advocacy work in fighting, and we're just advocating for racial justice. So, you know, when I first came, I had to figure out, well, how do I build this community? I had to learn and listen and learn and listen to people and figure out, what do they want? How do they want to see things for the initiative? Because I'm the first director and they wanted me to just create everything. So what do? I do what a good data scientist does. Took all the qualitative, quantitative data, did a cluster analysis to kind of figure out the common themes as far as what people want, what they don't want. And so really our purpose is to leverage our history in social justice to support data science research and teaching and addressing data really for Black lives. And the way that we do this is through two goals. One is to develop talent, and the other one is in the creation of new knowledge. And we do this through three modalities: through our curriculum development, through our research development, and also with our engagement, both locally and globally. So how do we engage with the faculty? Well, everybody loves a high five every now and then for the hard work that we do. So we really wanted to highlight the faculty and their work and really bring them to the forefront. So in April, we hosted the inaugural W.B. Du Bois Data Science Symposium, and where we featured our faculty. They did 5-minute lightning talks. Their videos are housed on our YouTube page where they could share their work, but we also had networking sessions so people could network. It was all virtual. It was the first one, and it went over pretty well. It was good. They really liked it. They liked the idea of being able to share their work and have this space, this interdisciplinary space where people had that same language of data science. So that was a lot of fun. And, you know, to have Congressman Jerry McNerney come by, he's from the 8th District of California. He's a PhD mathematician on the House of Representatives in the US Congress. And then our mayor, Keisha Lance Bottoms, who's awesome and amazing. Her son goes to Morehouse. So what else do we do with our faculty, right? So my thing is, so when I first came, people said, are you going to work with students? I said, not yet. I have like that airplane model where, you know, if you're, I'm not saying we're crashing, but if you want to address something, we'll say you put the face mask on the parent first and then the child. We wanted to equip the faculty, the researchers, and create an innovation ecosystem in which students could thrive. So our first round was to work with faculty. So we hosted about 9 summer workshops, anywhere from intro to data science, to Tableau, to R, to Python. These workshops were open to graduate students, faculty, and staff. So we had staff researchers come in and participate. You know, we actually initially started with 6 workshops, but the demand was so high, we had to bump it up to 9. It was a lot of fun. And people said they really liked being able to come together and talk about data science and just explore new areas. And we expect that these workshops, and they are, enhancing both their research and teaching. We also incentivized the research through mini grants. So we put out a call for mini grants, and we awarded 22 of them, where a person could either do curriculum development, summer research development, or hold like an institution-wide program. And so we're getting in their reports at the end of the summer, and the idea is to take that and then position them for external funding to help them continue on their research trajectory there. We also have a faculty and staff affiliate program where we bring our affiliates together for different opportunities to engage. This past summer, we invited our affiliates for like just a director's lunch and learn. Because I said, if we want our mini grant awardees to go out and get external funding, maybe we should talk about, you know, some of the process of that. So we talked about, well, I talked about, because I'm the director, ways to develop an online presence, how do you write winning proposals, and I had some friends come by there, and then also just how do you navigate research.gov and Fastlane. And this was, we actually had faculty who were incoming in the fall attend this. And so it wasn't just the current, it was faculty coming in. So that was really great just to have that community and network. So going on to the second set of questions is, what is the best way to plan out workforce and curriculum development? And then what are the resources needed as far as support and staff? So when I first came, I said, okay, it's kind of virtual learning in this ever-changing environment, right? I said, where's the virtual computer lab? And people are like, what are you talking about? I was like, we need a virtual computer lab. We can't, it's challenging to do data science if you have students off somewhere else and we all have different sort of packages, software, and that sort of thing. And so I told the students, I met representatives from Coca-Cola and SAP just through LinkedIn. So LinkedIn is a great networking. And we still meet, we met this morning, and we have an ongoing partnership with them. They actually worked with us, met with us, and we kind of said, well, where can we meet? And they were like, how can we help? So we arrived at this virtual computer lab. So they funded it back in December of last year. And they even went so far as when we went to the tech demonstration, they came along with us, and we were all kind of, I guess, teching out over the platform, which actually served to be really good. We used it in our workshops, we're using it in our teaching, people are using it in their research. So it's just a virtual desktop interface, no download, but it's an interactive where if you're the instructor, you can see all of your students' screens sort of thing. So you can go and help them if you need to. Of course, the students can turn that off if they want to. And we did that in collaboration with the Woodruff Library. So that was great as far as resource building. So how are we thinking about curriculum? The way we're thinking about curriculum really is through how are our faculty thinking about curriculum. So what we did in the fall was we developed a data science minor team to come together and develop what we would call an AUC Data Science minor. So we have 3 of our institutions are undergraduate institutions. They are very different. They have different missions. They're different institution types, right? So they're not the same. But we wanted to come together and think about what should a minor in data science look like? What are the outcomes? What are the common themes? And then each institution will go back and then flesh out the details, but we would have the same high level theme at each of the institutions. And so we arrived at this structure for our minor, that our minor would aim to prepare our students to obtain, process, analyze, and present complex data, including data related to the African diaspora. So we are a consortium of historically Black colleges and universities, and we want to make sure that we really address data science in relation to the students that we serve and be intentional about that. We identified 6 learning outcomes. First, math stat. Everybody loves statistics, right? And then the second one's programming. Third one is modeling. Fourth one's data curation. Fifth one is ethics, and the 6th one is communication. Now, some places they'll lump together ethics and communication, but our team said, no, each one is on its own. And even though 3 of our institutions are undergraduate, we thought it was important to have everybody at the table. So we did have a member from Morehouse School of Medicine, and we also had somebody from the library, and because the library is thinking about resource, and Morehouse School of Medicine has a lot of programs that run across the institutions. So that was very valuable. And if you're thinking about, were they all data scientists? They're all over the place as far as disciplinary fields, from business to chem, comp sci, community health, biology, poli-sci. Yeah, so the members came from a lot of different traditional disciplinary domains. It did take us a minute to figure out a common language. And then once we kind of coalesced, then it was like, oh, well, this all makes sense here. But it really was intensive work to arrive at a structure that everyone would agree on and also would feel good about. It's one thing to agree about it. It's another thing to actually feel good about it and that it can make positive change. So they're still working on this. We anticipate that the minors will go through review and hopefully be in by January. With all the uproar in higher education, with the changing climate, let's just say it's been interesting. As we know, education doesn't always start and stop in the classroom. So we also ran a data science challenge in the spring to engage our students in a topic, in this case, on erasing child trafficking by looking at text data from Facebook posts. How can we make Facebook posts that are more resonant and that can actually address child trafficking? And so we did this in collaboration with University of South Carolina and also Emory. And the students, they rose to the challenge, and we had first place Clarkites. That's the abbreviation, Clark Atlanta University sort of thing. So that was a really neat way to have students really dig into this important problem that I didn't know this before I came, but this is a really big problem here, and specifically here in Atlanta region. We also supported summer programs, one at Clark Atlanta that had two kind of, tracks. One was a summer undergraduate program in data science, research program in data science. And the other one was for faculty, to get faculty into data science. So both of those had training component, but they also had a research component. The faculty had to write a proposal by the end of the summer, right? And the students had to write a research paper. It could be one and the same, depends on how you do it. And so it was interesting, they had these two concurrent groups kind of interplaying through the summer. So it was all virtual. At Morehouse School of Medicine, they did a data science summer bridge program in biotechnology and bioentrepreneurship. And got to say, Morehouse School of Medicine has like the #1 biotechnology program. And so this program really is just to get students into this field of health data science. Data science, AI, ML, if you look at NIH, AIM-AHEAD program or these other initiatives, it's really in the health sciences field, artificial intelligence, machine learning is big and it's expanding. So this is something that's really blossoming at medical schools. We also hosted an open doors by open source programs to upskill postbacks in open source software development. A lot of, let's say, data science programs, come out of this open source software development, we'll say culture or ecosystem rather. And so we had a summer program with students where they would upskill and they got professional development. But then we also said, well, okay, so the students did it, we trained them. How can we take what we learned there and embed that into the curriculum? So this fall, we're going to have a faculty work group look at what they did in the summertime and develop ways in which we can put this into our curriculum. So there's that sustainability piece. And the faculty in the working group, it's faculty members from across the AUC. They're not all computer scientists. We do have a computer scientist. We have data scientists from the med school. We have somebody who does women's studies and religion. We have, I think the other one's political science. So it's not just for computer science or math. We really do see data science across the fields. Another example of how we bring faculty together to develop this curriculum is our pre-freshman experience that happened this summer. The way in which this worked, they say, if you get more minds at the table, you get a better product sort of thing. I think that's what happened with this program. So I had a working group of 4 faculty members. So there was a computer scientist, an economist, and a chemist, and an education researcher, right? These 4 and myself formed a working group where we developed the structure of this program experience, developed the outcomes, and developed all the survey instruments. And now we're writing a paper together about this program. And so we had about 32 incoming students who are incoming to the Atlanta University Center work on different data science projects with faculty members, and they had a research mentor. 1-week program. So, I mean, if you didn't like it, it'll be over in 5 days, right? But if you like it, let's continue this. So really it was just, let's dip your toe in the water of data science and just kind of see how it is, build a little community before you come, but it doesn't have to be completely overwhelming. It's 1 week. By the end of that first week, they gave a midway presentation on Wednesday. And on a Friday afternoon, they gave a presentation and people were like, oh, it's being recorded. Whoever's listening to this, I didn't say this. They were like, wow, these presentations, they were better than program. So their presentations were actually very, very good. Like I said, they're incoming students. They were using Python, R, Excel to analyze data and get the graphical results. And so it really was neat to see them explore different topics. And when I talked to Dr. Pang, he looked at data analysis on internet information disparities. I said, Dr. Pang, how did you like it? He said, it was great. You just gave me all the good students. They were actually all good students. He said, I would just give them a topic and then we would just run with it. And we were able to follow the students. So they really liked it. And it was diverse topics. We had majors from all of the majors. I don't think we had, I think maybe there was no one popular major sort of thing. So it was people from across the disciplines, both like in the humanities, science, art sides. One thing that we had in that program was guest presenters. We had, so I kicked it off with what is data science? And then how do I use data science for social good and positive change? How do I succeed in college? And then the last one was, I think this is my favorite title. What does a data scientist really do? Someone asked, well, what do you want me to talk about? Like, answer the question. So we had different speakers come in. Some were graduates of the center, but they were really just, people who just talked about, here's how I use data science. Here's how I have positive change. And also the students could sit there and see somebody who looked like them. That was important. And, but it was a great experience. The panelists were amazing and fantastic. This fall, talking about faculty and curriculum engagement, we'll be bringing AI for All to the Atlanta University Center. And our faculty lead, we always like to have faculty leads, is Professor Yvonne Phillips at Morehouse, who essentially, this is an interesting way that we're doing it. This is not how AI for All intended this to be. So AI for All is like a nonprofit. They're pushing AI and they've been really active in the K-12 space. Now they have 8 university partners and they want to provide AI training and access with a focus on underrepresented groups, right? And so, but we said, well, how are we going to do this? We have Professor Phillips, who's helping us basically build a wraparound course. It's like AI for All is a book, and then she's building a wraparound where they still have to read articles, they're going to do research, that sort of thing. And so we're really anxious to see how she will develop this, and we're developing it along with her. We don't exactly know what the end product will be, other than we're going to have some really fantastically trained students. So like I said, education doesn't only happen in the classroom. We also have a data science seminar series where we go between topics, anywhere from research, teaching, to community engagement. They're all posted on our Facebook and YouTube, anywhere from COVID to cancer, to data in the Black vote, to today, which was tips for getting a data science job. It's kind of like, let's start the academic year off right sort of thing. So yeah, and it's posted, like I said, in our Facebook and YouTube. So the last set of questions is looking at sustainability, funding, and pathways. So, whenever we start with these things, how do we do sustainability funding? And then what is this thing of advisory boards and how many should we have? So these are things that we think about if we're starting a research center. So we have, I have an interesting structure in that I don't live in any school, but I answer to all of them happily. So I report to, so for day-to-day, I have an executive director I report to, and that's in the consortium. But I also have a direct line to all 4 provosts and the director of the library. So that's shown on the left. That's the Council of Chief Academic Officers. So I report to all of them. I have dotted lines to the 4 presidents. I also have a faculty advisory board that's made up of faculty across the AUC, where they provide advice on how to do, where we should do, how we should go. And so having this input really helps us see and engage with multiple facets of the institutions. We also have an AUC Data Science Club, which is undergraduate and graduate students. So I also meet with them regularly. So I see all these different, we'll say, stakeholders in our ecosystem. So we make sure that we really are providing a community of data science. And then, with money, right? So we have seed money, but I stay awake at night, try to think, well, how am I going to sustain, right? How are we going to do this? So I write a lot of grants, right? Okay, anyway. Somebody said when I first came out of NSF, they were like, welcome to the real world. Now you get to write them. I'm like, oh my gosh. on the other side, I just, processed, managed, did the merit review, all the rest of that. So anyway, so we just got this one funded a few days ago. Hopefully we'll have 2 more in the queue. But this one is in the public domain. So this gives you an idea, at least what we're thinking about and where we're heading. So this is a project on identifying assets and collaborative activities to support student success in environmental data science at MSIs. So this is data science, but looking at environmental data and leveraging the expertise, intentionally leveraging the expertise at HBCUs and also tribal colleges and universities to essentially build a network, identify barriers to data science education so we can address them, and then also enhance this field of environmental data science through the lens of diverse perspectives. So I'm really excited about this project. We have another one that will coming out that will link us with HBCUs and HSIs, but I don't want to jinx anything because, just waiting on NSF to press the button. But we're really excited about this. So this was funded. We have a few more in the queue, but really the funding is a challenge because since I don't live in the institution, I don't have a development person allotted to me. So I'm kind of in a figured out situation. So I'll just say it's an interesting ongoing challenge. So, okay, so now you know a little bit about the Data Science Initiative. So what are the things so why do I do all of this, right? There's so many unknowns, there's so many questions. I answer to all these people. I have, sometimes I'm thinking, what did I do? This is why I do what I do, to really address some of these societal challenges in data science. So I'm just going to share a few of those. So one's on predictive policing models. So with predictive policing, you're really trying to look at, can you predict what and where something is likely to happen to minimize risk? So you collect data, maybe you can predict where crime will happen or not, that sort of thing. And these predictive policing models are designed to learn and reproduce patterns in data. However, garbage in, garbage out. If you have biased data goes in to train these models, then the models can amplify those same biases. And so this really came under question. I mean, it's been under question for a while, but I guess you could say it hit the mainstream, we'll say, this last year. So this quote says, using Predpool in Oakland, California, Black people would be targeted by predictive policing at roughly twice the rate of whites. This is in contrast to the estimated pattern of drug use by race, where drug use is roughly equivalent across racial classifications. That's a problem. We would like for our models to predict accurately and not exacerbate our own biases that could unintentionally or intentionally cause harm to groups of people. So when I went to ICERM, it's the Math Institute at Brown, in 2016. I went to a predictive policing workshop because I was curious as to what it was. And also, when I looked on the roster, I didn't see any U.S. underrepresented minorities. I'll say it that way. People like to mix. I'll say U.S. underrepresented minorities. And so we looked at police patrol analysis. So like when you call 911, they say, hi, this is 911. How may I help you? And then you say, hi, somebody's making a lot of noises. And so we looked at, can calls for service data be used to measure quantitatively the effect that patrols have on crime? So we had this spreadsheet, it's from Providence Police Department, and we're just kind of assessing it. And so I did a geospatial analysis plot looking at where the noise disturbances happen. So in the upper left-hand block, that's from like midnight to 6 a.m. So you see a high peak red there in one part of it. And then 6 a.m. to 12 p.m. it starts to die down and so forth and so on. I was like, well, what's in that red dot? It says Providence College. I was like, okay, that's okay. But I said, one of the things I wanted to look at was, what is the response time of police based on where people live? Because when I grew up, the saying was, you could get the pizza faster than the police would come to your house, sort of thing, when you live in the Black neighborhoods. And so that's that's where Flavor Flav comes in. But since I was the only US person of color there, that was not resonant with their experience. So it's kind of like, why would you want to do that? And why is that important? And and when I talked about this, actually in my class the other day, I had a student who did a research experience, and I shared this with her, and she said, you know what, I had the same thing in my summer research. I was like, we have this bias against this certain demographic. Do you all not see this? She said she had to fight all summer, and finally at the end, it was like, yeah, you're right. And so sometimes, and for me, we need more diverse perspectives at the table, so we don't have to be a lone person really advocating to look at different aspects of the data so that we really can understand what's going on and not use it to validate our own assumptions or our own judgments. And so last year, there was a group of mathematicians that actually called for people to stop working with police departments, giving the happenings last year. Now, happenings is not the right word. But, and so I actually, put on Twitter, it says I went to that predictive policing workshop that they had talked about in that article. And I said it was the hardest, most spiritually draining math workshop because it was the mathematicians who dehumanized the data. So the data really, in my mind, is linked to people with lives. And that has to be respected and understood in order for us to really interpret the data to bring about any positive change. We also have AI being used in drug discovery. So this is just a snippet. This is from BenchSci, where they're using AI to find hidden connections and new insights and diverse linked data sets at data to discovery. And so people are using a lot of AI in the health sciences. Maybe you have different data sets that you want to talk to one another. Health data can be interesting, sometimes hard to get to because there's privacy concerns for obvious reasons. But when we're talking about AI and drug discovery, it's becoming more and more prevalent. So here's just a diagram, right? Here you are, the patient, you go see the doctor, right? So the doctor will see you now. How machine learning and AI can extend our understanding and treatment of asthma. So the person goes to the provider has a sample population, puts maybe some biometric data into the model, medications, history, and maybe the model takes into account environmental, omics, everybody loves omics data, social determinants of health, claims data, and so on and so forth. And so this is fed into the model, which then comes back to the provider, which will inform how they treat the patient. The challenge is if this patient population is not represented of diverse groups, we could providing care that will mistreat people if we're not all represented in the data sets. And so, yeah, so that's a challenge. Back in March, the FDA put this out. It said that it was a COVID-19 update. It says the FDA authorizes first machine learning based screening device to identify certain biomarkers that may indicate COVID-19 infection. So we're seeing machine learning have a really strong influence in how we are treating healthcare and medicine, which could be a major plus, but we also need to make sure that we're doing it in the right way because people will be impacted by the decisions that these devices could make, let's say, this is a bad way to say it, could make for the providers or could suggest, we'll say, to the providers. So we need to make sure that these models really incorporate the people, the culture, the climate, all of this, so we don't end up doing harm. Nature Medicine, back in April, they put an article, How Medical AI Devices Are Evaluated, Limitations and Recommendations from Analysis of FDA Approvals. So they looked at these FDA approved devices, and they said that even though the device approvals have increased, multi-scale reporting and sample size has stagnated. So here's the median sample size in that curve, and then the bar are these AI devices approved at the top. So even though we have more devices approved, the study sample size goes down. So the question is, right, are we really is the sample size big enough to inform a model? It's a question, who knows? We also have how medical devices are evaluated, limitations and recommendations. So this is just looking at different parts of the body and looking at the risk. The squares here are the high risk for the head. but we have different AI devices that are help treating different parts of the body. So I mentioned that, if we don't do these things right, it could inflict harm. Here's an example of one. That last year, this was in the New York Times, 2020, Robert Julian Brock Williams, he's coming home from work, and his wife and kids are on the front lawn. The police come up and handcuff him and arrest him in front of his kids and his wife there. I don't know what I would do as a parent if I was handcuffed in front of my kids. That would just, I don't think I have any words for that. But he was accused of stealing from an upscale boutique. And the Michigan police use data work software that employs facial recognition based on machine learning. And so the algorithms from these companies were known to falsely identify African-American faces, but these companies are still being used for policing and facial recognition. I mean, they took him downtown, mugshot, fingerprints, all the rest of that. He said it wasn't him. They didn't believe him. And then the next day they finally, released him. They were like, I guess the computer got it wrong. But I mean, the impact of trauma on the wife, the kids, seeing their father being handcuffed in that manner when it just wasn't him, it's harm beyond my imagination. So when we talk about these machine learning, I think of the people who this impacts, and we've got to get our algorithms and our data science right. Timnit Gebru has been in the press for essentially being pushed out of Google, we'll say it that way. So she co-authored a paper called Gender Shades. So she was looking at the accuracy of these facial recognitions in gender classifications. So she looked at 3 different systems shown here. The first one here is a darker male, and this is accuracy in the gender classification. So if you're darker male, it's, for the first one, we'll say it's 88%. Darker female, it's only 65.3% accurate. So if it's darker female, your face will not be recognized, probably more often than the other ones. And here, she just has the largest gap between the lowest number and the highest number on each horizontal line, basically indicating that if you are a darker female, you're going to be misclassified more often than you're more likely to be misclassified than the other folks. And if we're using facial recognition, she wanted to make it clear that we need to be transparent and we need to be accountable for the AI we do, because again, it impacts people. So she wanted to publish this paper. Usually it's kind of like, hey, look at it and kind of push it out, but Google's had said it didn't meet their bar for publication. So yeah, that was a bore. If you haven't read about that, I would read about it. But she's still active, thank goodness. She co-founded Black in AI. And of course, the Google CEO apologized and vows to restore trust after Black scientist outer. That was the NPR. We also have another example here of voter suppression. This was from the Miami Herald back in 2020, how the Trump campaign used big data to deter Miami-Dade's Black communities from voting. So essentially what happened was the folks that took the voter data, then developed a computer algorithm that analyzed the data, looked at like all their social media, that sort of thing, to learn how to manipulate the voters to not vote. So you can think about this as the modern day Jim Crow, but using data science to carry it out in this case. So these voters were actually marked for deterrence, and 25% were Black, even though they only made up 13% of voters. So they used, this computer algorithm kind of spit out what advertisements, disinformations, and misleading messages could be used to get people to not vote. So there was a Senate Judiciary Committee back in 2018 where they said that Cambridge Analytica offered voter disengagement as a service in the United States, and there are internal documents that I have seen that would make reference to this tactic. The firm would target African-American voters and discourage them from participating in elections. So this is another example of how machine learning really disenfranchises and really is definitely not, I don't think, used for the greater good. So these are things that keep me up at night. I think about the people this impacts. I think about how our technology and data science, how what we develop impacts people. And I've kind of mentioned Du Bois throughout. So if you didn't know, Du Bois is actually a data visualization innovator. That's what he's known, one of the many things he's known for. So he's at his desk at Atlanta University. So he was a professor of history, sociology, and economics at Atlanta University. And he did this exposition in Paris on the American Negroes and used visualizations to tell the story of American Negroes and what was happening. So on the right-hand side, that's a book you can, with everything else, you can buy it on Amazon. And so it talks about the different visualizations that he made, and he did them by hand, but he really was a pioneer on how to represent data in a picture. So that spiral, right, there's a Du Bois spiral. Well, this is the assessed value of household and kitchen furniture owned by, quote, Georgia Negroes. And so the top bar is 1875, that's the value. So that just, that top little segment there, that's kind of in that rose colored. And then if you go down one more, the lines get longer. So that's 1880, so the home value goes up. And then 1885, it goes up because the spirals get longer. And then all the way to this inner one that's in red through 1899, arguing that the home values significantly increase. And he gives a tongue-in-cheek recommendation, comment saying that it's not because of the US government, right? It's probably, I guess, from his point of view, I think it was in spite of. So he took the stories, took the data of folk in Georgia, Black folk in Georgia, and talked about what was going on using these visualizations. So if you haven't seen that book, check it out. It's a great book. So one of the things, so the grad student, when I met with the grad students earlier, that we had briefly talked about this as one of the things that's happening here in the Atlanta University Center. So at the Morehouse School of Medicine and their Satcher Health Leadership Institute, they have a health equity tracker. Essentially, it's an interactive health equity map of the United States in looking at social determinants of health as related to COVID-19. And it's really looking at this health equity impact and really keeping in mind different demographic groups and being sensitive to that. And so Morehouse School of Medicine, their mission is health equity since the beginning. And so this is a really exciting ongoing project. And if you haven't checked out their platform, I think it's pretty cool visualizations. So what's the team that I work with? Well, I think they call us a small but mighty team. So I have administrative director, Bettina Gardner, who makes all things run. Manoa Farmer is our data analyst to make sure we do our data sort of things. And our communication specialist, Tommy Taylor Jr. In our team, we're really committed to advancing data science, AI, ML, cybersecurity techniques that address both ethics and bias, with a focus on topics that impact Black America. And if you haven't seen it yet, on Friday, September 24th, next month, we're going to have a student data science symposium, data for the students by the students. So this will be a really fun event. So we're looking forward to it. And with that, I will take any questions.
Thank you, Dr. Washington. So now we open to questions.
Hi, Talitha. This is Marcia. I am wondering if you have developed any materials for curricula that other faculty could use in their courses.
Marcia, you read my mind. So we're building that. Yeah, we're building that. So our faculty do a lot of curricular innovations, but we're kind of, research is the reward. But I'm like, y'all doing some really cool stuff. We need to pump this out. So that's what we're doing. We're starting with PFx. And even so in the working group, we had another meeting. I said, do we talk about our curricular? Is that something that we do? Because I'm still, even though I'm a year in, I'm still learning all the intricate details. And they were like, not really, we just do it and move on. I was like, okay, I see the challenge. Yeah. So come back and ask me in a month when maybe somebody up there in Alexandria presses a button. Yeah, ask me in a month. Yeah, so we're working on that. I don't want to jinx it, but yes, we're getting for the PFX, we'll get that out as a resource, and then this other course we're building with AI. And then we also have a data science in the African diaspora.
Great.
That's built. So yes,
Great.
it's still under development. I think COVID kind of threw.
Right. Well, yeah, I mean, it would be wonderful to have some resources on data science, the intersection of data science and social justice for just data science courses, and just integrate them into the course material.
Yeah. And hopefully if you ask me in 2 weeks, I can tell you. Yeah. But yeah, that's coming.
Oh, there's a question in the chat. Always, do you want to ask yourself?
It says, as a statistician, what are ways we can avoid dehumanizing the data or to inject bias into the analysis? I think, I think about my student, right? I have a soft spot for students, right? Even though I may be hard on them. So, so being able to say what you don't know, right? And being open to hear that there may be realities different from one's own reality. So there are different things that happen in different pockets of society. There's no way one person could understand all of those pockets and how they interact. But being, one thing in research is it's important to know what you know, but it's probably more important to know what you don't know. So I think we can't ever get that arrogant or have that big of an ego in data science where we claim to know and have that over encompassing. I think that the humble approach to say, this is what we think. Now, wait a minute, let's take a step back. Is this really what's going on? But then also, if we're working with data sets that are connected to different groups, bring different groups in as equal partners, but not as a, like this, actually have a level playing field of respect and collaboration, that sort of thing. We do have institutions that will come to us and say, hey, we want to partner, but then we're an afterthought. I'm like, wait a minute, no, that's not how. But bringing in people that impact your data sets and come with an air of humility and say, this is what we're thinking, we could be wrong. Point us into that direction and ask the questions to really understand what you don't know, right? Because it's going to be a lot. And when you have somebody throw a curveball, to not dismiss it, but to actually really think about, is this something that, how could this bring value? Is this something that we need to look at? That's just my 2 cents. But we all have bias, but that's why, I'm fortunate I have good friends with strong opinions. So they can check my bias at the door, well, sort of thing. So it's good to have people around you who don't think like you. And that's one of I think the things I like about this job. One of the things I liked about running data science panels at NSF, I would have all these different people from all these different fields. Nobody thought like me because they're all kind of over here, over there, that sort of thing. And so I like being in that intersection of these different ideas, different spaces, and really kind of think across the fields. But I think that's just my curiosity. I remember, I was telling somebody that I actually taught a course in humanities, like what mathematician does that? So I did a discussion course on race politics, that sort of thing. But it was all in humanities, the whole, so I called my humanities friends. How do you all teach classes? What is this, right? Let me learn from you. Let me be your student. So I think as data scientists, we need to have that attitude with those who we serve. Not saying we're going to come in and solve your problems. It's what really is this? I don't know this, right? Can I learn from you? How can I learn from you, sort of thing? And to also understand that could also be a burden, and to be sensitive to that as well.
I have a question. So for the data science to be impactful for society problems, then the important ingredient is data, right? Sometimes it's very limited and we have limited access to data. Do you see this as a problem?
Oh, yeah, I know, right? There's always the unknowns, right? I always say you make the decision with the information you have, but don't be so hold on tight to that decision or tight to that analysis that you can't be flexible and pliable, right? As I told the students, one of my favorite quotes is actually from Chris Bois, is never be so sure of something that you wouldn't take something better, right? So with data, there's always going to be a hole, and you kind of always have to go in with, I don't know everything, and this may change. There is no certainty. I may be looking at this wrong. Let me keep having those checks and balances just to make sure, but to go forward in like with a good spirit, good faith, that you are working towards a viable, let's say, on a viable path. But you know, we live in an imperfect world. We're imperfect people. You should watch me dance. A lot of imperfections there, but just kidding. It's still true. Anyway, but really it's having that flexibility to say that, you know what, this could be wrong. And when you get more information, don't take it personally, just take it as a new challenge.
Great, thank you. Any other questions? If not, then we thank our speaker again. Thank you, Dr. Washington, to give us a wonderful talk.
Thank you. Good to be in Carolina, virtually.
Dr. Washington, so do you want a copy of the recording, right?
Oh yeah, please. So I can send it to my friend.
Okay.
So I can finally answer her questions. Thank you so very much.
Thank you. Thank you for coming.
All right, thanks. Bye.
Bye.